Hello, pre-calculus students. Sorry I am not here today, but you guys should still be able to learn a little bit with this video, so please pay close attention. The homework that's due today, just hold on to it. I'm going to be collecting homework 18, 19, and 20 on Friday. But now I would like you to turn to page 8 of your chapter 3 notes and go ahead and get out your calculators. Scientific calculators are fine. Just need some calculators for some basic calculations. And so we're on page 8 of the notes, and the first problem we're going to do is this problem about a projectile being fired from a cliff. So there's a projectile is fired from a cliff 200 feet above the water at an inclination of 45 degrees to the horizontal with a muzzle velocity of 50 feet per second. There's a lot of information there. You don't need to worry about it too much because they give you the equation already that models it. So it tells us that the height h of the projectile above the water is modeled by this equation that they gave us. So this equation that they gave us has two different variables. It has x and h. So you need to know that x is the horizontal distance from the cliff, and h is the vertical distance above water. So x is like your typical x, and h is like your y in this equation. So h depends on x. And then also, if you look at this equation, it's kind of messy with the negative 32 over 50 squared. So I like to simplify it. If you divide in your calculator negative 32 divided by 50 squared or negative 32 divided by 2500, you get negative 0.0128. Make sure you have this 0 in front of it because that will change things. But notice everything else is the same, plus x and plus 200. You can use either form, but I find this form a little bit easier with having a decimal coefficient. Okay, let's start answering these questions. So part A says, at what horizontal distance from the face of the cliff is the height of the projectile a maximum? Since it's asking for the horizontal distance, and we know that x stands for the horizontal distance from the cliff, it's asking for the x coordinate of the vertex because the vertex is going to be where the maximum occurs. So we use negative b over 2a. Notice in this equation, b is 1 and a is this negative 0.0128. So we're going to do negative b over 2 times a. When you put that in your calculator, you get 39.0625, and that's how many feet it is away from the cliff. So that's the horizontal distance it's asking for in part A. If you move on to part B, it says find the maximum height of the projectile. That's still using the vertex, but this time it's the y coordinate of the vertex, and more specifically in this problem, the y is h, so we're finding the h value. But what we're going to do is plug in the x coordinate of the vertex, and I'll give you time to plug that into your calculators. And then when you simplify it, it rounds to about 219.53 feet above the water. Remember that h is the vertical distance from the water. Okay, part C says, at what horizontal distance from the face of the cliff will the projectile strike the water? Now remember that x stands for the horizontal distance and h stands for the vertical distance. And remember that it's the vertical distance above the water. So h will be 0 when it strikes the water because it'll be 0 feet from the water. So you take your h of x equation and set it equal to 0. Because it's a quadratic, we need to use the quadratic formula. So remember that we're going to do negative b, so negative 1 plus or minus the square root of 1 squared minus 4 times a, which is negative 0.0128 times c, 200, all over 2 times a. So go ahead and try this in your calculator. You're going to want to do the positive and negative form. I'm going to show you guys how to do it on Desmos. So I'm going to have a fraction, and I have negative 1, and I'm going to do the plus version first. And so plus the square root of 1 squared minus 4 times a, which is negative 0.0128 times c, which is 200, all over 2 times a, which again is negative 0.0128. So that's my first answer. That's with the plus and the plus or minus. And using your graphing calculators, you can go and grab it. Desmos also lets me copy this. So I'm going to copy this whole thing and change this plus to a minus. And now there's our second answer. So we have two answers, negative 91 about and positive 170. So going back, it helps if we look at a graph. So we have these two answers. Now, are both of them valid? Is one of them valid? So we look at, if you look at the picture, a lot of you probably know already which one is valid, but if you look at the picture, these are actually the x-intercepts. So this is the graph of that quadratic. Right here at the y-intercept, which we're actually going to do later, is where the cliff started, where the projectile was shot off, and this is where it hits the water. So only this positive number makes sense. So the answer is the projectile will strike the water 170.02 about feet from the cliff. So again, we used the quadratic formula and we figured out that only the positive number worked. Okay, so we're actually going to skip parts D and E for now. They have to do with the graphing calculator, and your chapter 3 test, you don't get to use the graphing calculator, but they are skills we'll work on later. So moving on to part F. Part F says when the height of the projectile is 100 feet above the water, how far is it from the cliff? So when it says 100 feet above the water, that's an H value. So you're going to plug in 100 for H. So very similar like what we did before, except we're plugging in 100 instead of 0. And then because it is a quadratic, we need to set it equal to 0. So you need to subtract both sides by 100, and then you get this quadratic set equal to 0. Now this is very similar to the one we did in the last part. It's just the only difference is your C value is now 100 instead of 0. So what's nice about that is we already have that set up in the calculator. We just need to change our C value in the 4AC part from 200 to 100. So I'm going to go back to Desmos again. You guys do this along with me on your graphing calculator. And I'm going to change the 200 to 100 in the plus version and the 200 to 100 in the minus version. So we again have two answers. And for the same reason as before, we're going to throw out the negative because the cliff started at the y-intercept at 0, 200. So anything before that doesn't make sense in our story. So the answer is going to be this 135 answer. So back to my notes, we have these two answers, and we're going to throw out the negative version. We don't want that one. And then to answer the question, when the height of the projectile is 100 feet above the water, the projectile will be 135.70 feet away from the cliff. That's approximation. That's a rounding answer. So again, we use the quadratic formula. Okay, so that's all the notes we're going to do today. Here's your homework assignment. It's also on Canvas. We're going to do a couple problems that are linear models, and then 4 problems that are quadratic models. And then you should also be finishing your Chapter 3 test review. And don't forget your Chapter 3 test is on Friday. You can sign up for flex time for Wednesday and or Thursday. And block day will also have some time to answer some questions before your test. Get to work and good luck.